In this video, I will show how to solve an optimization problem that involves maximizing or minimizing a certain function. For example, here, let's read the question. So the question is, what dimensions will require the least amount of fencing? So the objective function, that is the function that we're trying to optimize, is the amount of fencing. So the amount of fencing in this case is the total length of the fence, so we can call it L, and the total length of the fence is given by the following expression. We're looking at the perimeter of this rectangle. Well, it's not even a rectangle, it's just 3 sides, so we don't count this. So the total length is x plus 2y. So it appears that the length is the expression of x and y, but we only know how to minimize or maximize the function of one variable. So what do we do in this case? Our only hope is that there is some sort of constraint that relates x and y. That way we can solve for x and y and then replace it into the objective function and then make it a function of one variable. So let's read this question again. What's the meaning of 245,000 square meters? Well, that's the area. So what does that mean? So the area, which is computed by the formula xy, the total area must be 245,000. So that means that y must be 245,000 divided by x. So area function in this case is what's called the constraint. So we use the constraint to solve for one of the variables. And now when I replace y in the length function with this expression, I don't have a y variable there anymore. So it's just a function of x, meaning we can optimize it. And to optimize it, we're going to find the first derivative. And the first derivative of this function is one minus 490,000 divided by x squared. We write this fractional function in factored form because it's easier to analyze it this way, and that means we would factor out the numerator and have the following expression for the function. Now we set it equal to 0 or find the values where it doesn't exist. It does not exist when x equals 0, and it's equal to 0 when x equals to plus or minus 700. 0 and negative 700 are not in the domain of this function, so we are not going to consider them, but we're still going to use them to construct the sign chart for the first derivative. And the sign chart will be the following. Because the multiplicity of x is 2, that means the function doesn't change the sign at 0. And we interpret the following signs as if the function was increasing to the left of negative 700, decreasing to the left of 0, decreasing to the left of 700, and then increasing after 700. And again, we only care about the function to the right of 0. And to the right of 0, we can clearly see that the function has a relative minimum at 700. So we can find the function at 700, but the problem is not asking for what is the total length. It's asking what are the dimensions that will guarantee that it's the least total length. So the dimensions are x is 700 and y is, to find y we're going to use constraints, so 245 1000 divided by 700. So it is 350. So the answer to the question is the dimensions are 700 meters by 350 meters.